So today I am going to discuss the second problem of attribute regular context 137. So we are given one binary array with of length n. We can flip some of the sub-arrays, contiguous subsequence of the array, and change its element to from 0 to 1 and 1 to 0 or vice versa. So we have to find the number of distinct number of ones we can get in the final array. So let us take the first example and check out. So this is the first example. Now if we take these two element this element and flip, the array will become 1 1 1 0, and the number of counts in 1 is 3. Here the count in 1 is 2. Now if we flip these two elements, then the array will become 0 0 0 0. The count of 1 is 0. And if we only flip this element, then the array will become 0 1 0 0, and the count of 1 is 1. So there are four different types of 1 we can get by flipping elements. Okay. Now so what observations we can make is that the first observation we can make is that if we are choosing a subarray which has c0 number of zeros and c1 number of ones, then the change in one will be what? The change in one will be c0 minus c1. So let us take one example, like if the array is 0 0 0 1 0 0 0 0 0. Now the count of c0 will be what? C0 will be 6 and c1 will be 5. So if we change this subarray, then the number of c1 will be 1. If we change flip all the elements of the array, the count of 1 will change by 5. Okay, so c0 minus c1, the count in 1 will change, c0 minus c1. So let's call it change or c. So c is equal to c0 minus c1. Okay, c equal to c0 minus c1. So we have to figure out what are the different values of c we can get in the array. So we have to choose some of the all the subarrays, and so what will be our brute force approach? Our brute force approach will be to check every subarray and find the number of zeros and number of ones in the subarray, and take calculate the value of c, push it into one set, and take the number of different distinct elements in the set. Okay, so the approach will be, I think, n square log n. The first approach which is coming to my mind will be n square log n with prefix max. Prefix array. Now what is the second approach? What is the more optimal approach we can make? The optimal approach we can make is that if the number of if the c is, let's say, k for one subarray, then for then we have some parts of the subarray which has k's value, c's value k minus 1, k minus 2 up to 0. Okay, so k is a positive integer. Okay, so I am saying that if the value of c is k in some subarray, then the subarray should have part so the sub part of the subarray should have c value k minus 1, k minus 2, and so on up until 0. So for this subarray, the value of c is 5. Now if we take this part only, this part, then the value of c is 4. If we take only this part, then the value of subarray is what? I think 3. And if we take this, the value of c is 3. For this, the value of c is 2, and for this, the value of c is 1. And for this, the only this element, if we don't take any element, then the value of c will be 0, and if we take this element, the value of c will be minus 1. Okay, so we have got for every value from k, like k is equal to 5, for every value from 5 to 0 we got in the subarray. Okay, so we have to figure out what is the maximum value of c we can get in any subarray. So we have to figure out max of c, which is positive, and minimum of c and maximum of c, and our answer will be this maximum of c plus minimum of c plus 1. So we have to figure out what is the maximum value of c we can get for any subarray, what is the minimum value of c we can get for any of the subarray, and plus 1 for 0. Okay, so let's take one example. So let's take the basic example 0 1 1 0, which was given to us first. So the maximum value of c is what? The maximum value of c is, I think, 1, and the minimum value of c is what? Minus 2, and our answer will be what? 1 plus 2 plus 1, which is 4. Let's take another example. I think the example will be what? 0 0 1 1 0 0. The maximum value of c will be what? The maximum value of c will be what? 2, and the minimum value of c will be what? Minus 2. So the answer will be 2 plus 2 plus 1, which is 5. So how we can calculate the maximum value of c and minimum value of c? Let's figure out. So let us take one array, like let's say this is b0 b1. Our array is like that. b0 b1 b2 dot dot bn. So for every index we will try to figure out what is the maximum value of c, and what is the maximum value of c, what is the minimum value of, let's say this is maximum value of c positive, maximum value of c positive, and minimum value of c negative. So we have to keep track of the transition from maximum value of c and minimum value of c, and we will also take the global maximum. So let's say global maximum value of c and global minimum value of c, global max c and global min c, and these two are current max c and current min c. Okay, so I will explain my code now. I think you will easily understand my code how I am tracking out the transitions. So let's take the example. This is the maximum value of, this is global maximum value of like positive for c, and it is minimum value of global minimum value of negative or global minimum value of c. Okay, and this is the current positive value, and this is the current negative value. So I think this is I have already explained what is current positive and what is current negative, and this is global positive and global negative. This is global positive and this is global negative. So if ai equals to 0, then our current positive will increase. If ai equal to 0, current negative will increase, and our current positive will decrease. Okay, and current positive will max of current positive and 0. Same way, if ai equals to 1, then our current positive will increase and current negative will decrease. You can do it in other ways also. The same thing will happen if we flip the position of this thing. If we take this part and move it into the this part, if we change these two codes, then it will be exactly same. And we are taking the maximum value of current positive and maximum positive, and we are taking the maximum value of maximum negative and current negative, and at the end we are taking maximum positive plus maximum negative plus 1. I think where I have explained in this in this diagram, I have explained if ai equals to 0, we are incrementing the value of c, and in my code I think if ai equals to 1, we are incrementing the value of c. So both the cases are same. You can just change this part of code and this part of code. The code will execute the same way, and the our answer will be right. Okay, so if you have any doubt, you can ask me in the comment section. Please subscribe to my channel and like the video. Thank you.